First problem.
Yeah, the test.
Yeah, from this packet. Yes, which one?
Question number 10.
Question number 10. So let's take a look at question number 10. In question number 10, we are given a function, and we are told that a ball is thrown upward and outward from a height of 5 feet. The height of the ball is f of x, is in feet. It can be modeled by this equation, where x is the ball's horizontal distance in feet from where it was thrown. Fine. Use the model to solve parts A through C. What is the maximum height? How far does the ball travel horizontally? And graph it. So we want to find the maximum height. So I throw the ball up in the air. It hits the ground eventually. It reaches the maximum. I need to know what is the maximum, and I need to know how far away from where I throw it up in the air, will hit the ground again. So what are we asked to do? What is the question here? Correct. All we have to do is find the vertex. So the x-coordinate of the vertex is negative b over 2a. Awesome. So we copy the minus, we copy b, which is 0.6, and 2 times a will be negative 0.2. We can already picture the graph, as I mentioned, from 5 feet away. The ball is thrown up in the air. It will reach a maximum height. This is the maximum height. This is how far away the maximum height was reached. And this is when it hits the ground again. Okay, so what is this number?
3.
Very good. It is 3 feet. So this is 3. How do I determine the maximum height? So this is 3 feet. How do I determine the maximum height? Very good. I have to determine f of 3. Have you calculated f of 3, Jeremy? Any questions? That's okay. Any questions? Can I help? Okay. So did you determine f of 3 by any chance? Can you plug it in? Can anyone give us f of 3?
It's 6.5. Oh, I didn't square it. Never mind.
So it's negative 0.1 times 9, plus 0.6 times 3, and plus 5. How much?
5.9.
Thank you very much. And this is in feet, 5.9. So this is 5.9 feet. Perfect. So now we want to determine how far away from the point of launching, if you want, will it hit the ground again.
So the maximum height is 5.9, and where it occurs is 3.
Exactly. So I'm right here standing at 5 feet tall, according to the model, and I throw it up in the air. 3 feet from me, it will reach its maximum, and the maximum will be 5.9, and later on it will hit the ground. So
So B, you're looking for X. Right?
So how, say it again?
You're looking for X.
Yes. So what type of x and how do I do it? Very good. Yes.
You substitute
Yes.
You substitute Y for 0.
Exactly. It's the x-intercept. Awesome. So this is negative 0.1 x squared plus 0.6 x plus 5 equals 0. And because you know me already, you know what I'm going to do next. Exactly. So 0.1 x squared minus 0.6 x minus 5 equals 0. This step is not mandatory. But it's easier when you use the quadratic formula not to have a negative quantity in the denominator of the quadratic formula. That's all. That's the only reason. So then negative b plus or minus b squared minus 4 times a times c. Since c is negative, I'm going to change this into positive so I don't have to use nested parentheses. You can say, no, I want to put it in there. That's fine too. So then,
You put that in the calculator.
exactly. You want me to show it, or can you determine it? If you want me to show it, I will. Yes? Do I have to show? I should get it ready anyway. Because they hid it here. I did email everyone for a reminder for the review at Randall Mills. I hope you can. The traffic should be non-existent at that time. You can go back. You can come in wearing your PJs. That's fine too, and then you can go back to bed. I just have to be in Fairfax by 10 o'clock.
So for
Yes.
plus,
Yes.
I got, it's like a long one, it's like 10.68.
Okay. Feet. And the other one should be negative because the other one should be right here.
Right.
And we don't care for it. We don't care about this other X-intercept. So this is it. So this is 10.68 feet. Any questions on this problem? And again, there is no credit given for you selecting a graph from here. We don't care about that, but obviously this is not correct. It crosses at 15. What is the y-intercept for this function, by the way? What is the y-intercept for this function? Of course, which we already knew. So this cannot be correct, this cannot be correct, this cannot be correct, so this is the one. But again, some of the graphs that I found, all the options, all of them are wrong, so be careful. You don't have to select anything from what they show.
So like for this question, we want to graph it ourselves?
This is it. That's all I want you to do.
Okay. So
No measurement units or no anything. I mean, this is not, the reason I'm saying there is no specific word for the graph is because this is basically a word problem. Look at the A and the leading coefficient and so on and so forth. I don't want any details. So this is good enough. Something like this. Good. Anything else? Other question? Next question. Anyone?
I don't know if it was really like the rational.
Yes, of course.
I don't really have an equation for it, but
Would you prefer type 1, type 2, type 3?
type 1 and type 2 would be kind of the same, aren't they?
Yes, very similar. Actually, very similar. There's only one difference. One of them has the horizontal asymptote 1, 5, 10, -3, whatever, and the other one has 0. That's the only difference from type 1 and type 2.
Oh, okay.
So which one? Type 1 or type 2?
Type 1.
Type 1. Let's say a -3 x plus 6 divided by x plus 2. Is this type 1 or type 2?
Type 1.
Because it has the same degree of a same degree. Perfect. So let's get our table going. Let's find the domain. And what would you do?
X cannot equal -2.
Yes, indeed, x cannot equal -2. So the domain will be this. And yes, I will factor out -3. To get it ready for something else.
So when you shade it like that, is that the asymptote?
Yes. That's a very good question. I will shade it even if it's a hole. This really signifies I cannot put a number on the -2. Better than just saying that it's a vertical asymptote, because it could be a hole. So if it's a hole, I will still do the same thing, just to signify that that is the domain. And if you ask me to plug in -2, I'll say, sorry, I can't. I mean, I can, but I cannot give you a number back. Okay, so does this factor disappear with any factors, identical factor from the top? No. Is this a hole or a vertical asymptote? Thank you, Eric. It is a vertical asymptote. Once I know that, I will immediately write infinities. Waiting for what? Because this is not enough. Waiting for the sign. Awesome. In order to find the sign, I cannot use -2 because it will be undefined. I have to use two numbers that are close to -2. One on the left, which is -2.1, and one on the right, which is -1.9. They are not points that will be plotted anywhere. I'm just checking with them. -2.1 on this side and -1.9 on this side. So let's try -2.1. What is the sign of this with -2.1? Perfect. What is the sign of this with -2.1? 1, 2, 3 negatives. Sign. Very good. Last one. What is the sign of this x minus 2 when x is -1.9? What? This is negative. What is the sign for this? Okay, -1.9 minus 2. That's okay. -1.9 plus 2. I have two negatives. Very good. Okay, what is the end behavior and the horizontal asymptote for this function?
Do you know the end behavior by the multiplicity?
Careful. Multiplicities are for X-intercepts. End behavior is end behavior,
Okay.
not X-intercepts, right? So what is the end behavior for this function and the horizontal asymptote?
Following.
That's for polynomials. Yes, thank you, Eric. Leading coefficient of a leading coefficient. Leading coefficient of a leading coefficient for type 1. Perfect. Thank you. Okay, let's plug in 0. I need a number here. I plugged in 0. Very good. Awesome. And now I want to find the X-intercept. And I'm done. Yes. So X-intercept is when y is 0, when the numerator is 0, in other words, which means x equals 2. Let's think for a moment and see if you have any questions. I have to plug in 0 to get the y-intercept, and I have to set y equal to 0 to get the x-intercept. A fraction is 0 only when the top is 0. The top is 0 only when x is 2. Is this clear? Yes?
Oh, yeah.
Okay, so let's try and make sense of this. We'll graph it, and then we'll check. Okay. It's going from -3, dropping to -infinity. Quite easy. From -3, dropping to -infinity on the left-hand side of the vertical asymptote. On the other side, from +infinity, we'll cross the y-axis at 0, 3, we'll cross the x-axis at 2, 0, and you will go to -3.
So is the y always before the horizontal asymptote?
Yes. The horizontal asymptote says where the function values are going when x goes to -infinity and +infinity.
Okay.
It's the same with the end behavior for x squared. What is the end behavior for x squared? +infinity to +infinity. But this one does not have an end behavior. Yes, it goes to -3 eventually. Yes.
Under the x equals
Yes.
-2, what does it mean then? VA.
Vertical asymptote. Okay? One more time. From -3, dropping to -infinity. On the other side, from +infinity, crossing the y-axis, crossing the x-axis, and approaching -3. Is it better? Okay. When we graph a function with asymptotes, what do we have to graph first? Very good, the asymptotes. Perfect. They're not part of the graph, but they have to be graphed first. So we have -2, x equals -2, and we have y equals -3. Now I will plot the points I have. I don't have that much, but I don't need more. 0, 3, and 2, 0. And now let's look again at the table. The table says from -3 to -infinity. Okay, from -3 to -infinity. One more time, from -3 to -infinity. Then from positive infinity, crossing at this point, and going to -infinity, -3. From positive infinity, crossing at 0, 3, crossing at 2, 0, and approaching -3 towards infinity. As x approaches infinity, the function values get closer and closer to -3. So this is the function f of x, -3x plus 6 over x plus 2. I don't want you to spend on this more than, I'm more interested in your understanding of the graph than specifically graphing it. Is this better? Good. Other questions? Is there anything else before we look at the last little piece of the puzzle for test 2? Yes, please. You had a question, Stephen?
No.
No.
No,
Okay. Okay. Anyone else? Anything else that you worked on? Anything else that you would like to go back to? Anything? Okay, so let's look at 3.6. This is the last piece before test 2. So test 2 a week from today. Please do not miss the test. Please, please. Okay. So it's polynomial and rational inequalities. Now, do you remember the applications? We looked at 2 applications last time with rational functions. Do you remember those 2? One of them was when a patient was given a pharmaceutical product, a drug for whatever disease, and the concentration of that medicine in the patient's bloodstream was measured. Did we look at that?
We did a heart rate one. I think someone had like a panic attack.
Right, right. Okay, so I think that was a polynomial. So we did not look at applications with rational functions yet. Okay then, so before this I like to look at 2 applications. Because I wanted you to understand the difference between polynomial or quadratic and rational functions. Rational functions have way more sophisticated applications than the quadratic. What did we do with quadratic? Okay, we threw a ball up in the air and we determined the maximum. Okay, good. But rational functions are way more sophisticated. Here is an example. If we did this before, you can stop me. Okay, so let's read. We're given a function. What type of function is this? Exactly, it's a rational function. Awesome. And what type?
Type 1.
Type 1. Perfect. What will be the horizontal asymptote? Indeed, 6.5 over 1. 6.5. Okay, so now let's look at the function. It's graphed in here. So let's try to understand the model. Okay, it starts here at 6.5. It drops drastically within, this is minutes, within the first 6 minutes. It has a minimum here, and then it comes back and slowly gets back to the horizontal asymptote. This is what it's supposed to do, right? Eventually. So in about from 0 to 66 minutes. So now we're ready to read. This function models the pH level of the human mouth X minutes after a person eats any food containing sugar. The graph of the function is shown here. Okay. Use the graph to obtain a reasonable estimate to the nearest tenth of the pH level of the human mouth 42 minutes after a person eats food containing sugar. Okay, that's not going to be very easy, but I'm going to say roughly 6. Okay. Part B. After eating sugar, when is the pH level the lowest? See, this is a way more sophisticated function than just quadratic. or even polynomial, right? So when is the lowest? Obviously, it appears to be the lowest after 6 minutes, and it's hard to read. I'm going to say maybe 4.8. Okay? According to the graph, what is the normal pH level of the human mouth? 6.5. Eventually goes back, assuming we stop eating sugar. What is the equation of the horizontal asymptote? Y equals 6.5. And describe what that means in terms, yes, we already did. Eventually, we'll go back to 6.5. Use the graph to describe what happens to the pH level during the first hour. We already did. During the first 6 minutes, it drops dramatically. And then, look, it takes almost an hour for the pH level in the mouth to get back to normal after a little piece of candy or sugar, according to the model. Okay, here's another example. Again, I just want to stress out how sophisticated these models are. It's not just throwing a ball up in the air and following a trajectory that is quadratic. So let's look at this. So what type of function is this? We're going to read it in a moment. Well, what type of function is it? Rational. What type of rational? Type 2. Very good. What would be the horizontal asymptote? Always. 0. So now let's read. It says, a drug is injected into a patient and the concentration of the drug in the bloodstream is monitored. The drug's concentration C of t, which is this, in milligrams per liter after t hours is modeled by this function. A lot of work was put into it. A lot of patients, mathematicians, physicians involved in finding or coming up with this function. The graph of this rational function obtained with the graphing utility is shown here. Use the graph to obtain a reasonable estimate of the drug's concentration after 3 hours. Be careful when you are given this information. You are really told that this is 0, this is 10, and every tick is by 1 unit. The same thing here, minimum 0, maximum 3, and these two indicate 1, 2, and 3. So with a scale of 1, in other words. So if I want to determine 3 hours, 1, 2, 3, I will say potentially 1.5 milligrams per liter, still concentration in the bloodstream. Use the function now. If I use the function and I plug in 3, I get 15 at the top and I get 10 at the bottom. 15 divided by 10 is indeed 1.5. And use the function's equation to find the horizontal asymptote. What is the horizontal asymptote of this function? And rightfully so. We hope, unless someone needs to be on a certain medication for a lifetime, we hope that any medication we take, eventually the concentration in the bloodstream will go to 0. We really hope that it's going to get out of our system, right? If it's just an incident. So these are the applications, and many more applications of rational functions. Percentage of smoking-related death. So this is another, as you see, another application with rational function. This is a rational function type 1. What is the horizontal asymptote for this one? Exactly. Yeah. So the applications are more sophisticated. Now, I think I said that 3 times. Sorry about that. So the other thing I was going to say is that you will see way more interesting, I would say, applications, although these two are, in my opinion, they're very interesting, in Chapter 4. Chapter 4 is full of applications in real-life situations. A few examples I can give you for Chapter 4. Earthquakes. The intensity of an earthquake is measured using functions from Chapter 4 when we get there. Another application is when you remove, since Thanksgiving is coming up next month, when we remove the turkey out, or take it out of the oven and put it on the counter, the temperature decreases using a function from Chapter 4. When we get a loan from the bank or from whomever, for a car, for a mortgage, for whatever, the monthly amount that we have to return, or the payment that we have to return, so that we return the loan, is calculated using the function from Chapter 4. So those are even more close to our heart, I would say. Okay, so this is the last piece, and I'm hoping that you are going to just look at it as a little puzzle. How many types of inequalities we know so far? We know 2. We know linear, well, I should say 3. We know linear, we know compound, those with 2 inequalities, and we know absolute value. So these are 2 more types. Again, more sophisticated than the previous one, polynomial and rational inequality. And let's start with the polynomial one. You want it greater than or equal to 0 or less than or equal to 0? Perfect. Good. So we made one up. We both contributed. How many factors do I see in this problem? 4 factors. What is the degree of this polynomial on the left? If, which I will not, if I choose to expand the polynomial on the left, what will be its degree? Exactly. Very good. So we're going to use a table. I accept any other method. I prefer this one. It's because I think it's self-explanatory and it's also easy for me to explain. X is the variable in the problem. It has nothing to do with these factors. It goes from -infinity to infinity. The first factor in the problem is x. The next factor is -x plus 2. The next factor is x minus 5. The last one is 2x minus 6. And what do you think? Just a wild guess. What do you think the last row will be? The whole thing. The whole thing. Since, of course, you already know me, I ran out of room. I'm going to call this a product because that's what it is. And put the word product here. Only because I ran out of room. Otherwise, I would have put the whole thing in there. Now, can anyone tell us what is the 0 or the x-intercept for this? Of course. Thank you. What is the x-intercept or the 0 for this quantity, for this factor? Awesome. What is for this one? Perfect. X equals 5. And for this one is x equals, good. I would like to, it just happened that all of them were, let me make one negative. Sorry. Okay, because I don't want you to think that there are no negative solutions in there. So let's make the third one negative. Okay, so now I would like you to give me all these numbers in ascending order. From left to right, of course. The first one will be -5. The next one will be, and then 2, and then 3. Perfect. So the first row, which represents the first factor, which is x, has a 0 somewhere. Under which number? Under 0, of course. The next factor has a 0 somewhere. Under which number? Good. The next one has a 0 somewhere. Under? Thank you. And the last one? Under 3. Perfect. What will happen to the product whenever one of the factors is 0? Exactly. When any of the factors is 0, the product will always be 0. Good. Remember we talked about end behavior for polynomial functions. What is this function? All of them are the same function. What function? Linear. What is the end behavior of a linear function? It's this, if the leading coefficient or the slope is, and it's this, if the leading coefficient is negative, or the slope is negative, correct? How many of these 4 factors have a negative slope? 1. So what will be the end behavior for that one? From positive to, that's it, that's all I want to know. I don't care about anything else. And what will be the sequence of signs for the other 3? That's it. One time a student asked me, how many pluses do you write and how many negatives? It doesn't matter. It doesn't matter. If you don't like the symbols, you just write negative. Do whatever you want. If you don't want to think in terms of the end behavior, plug in a number. So, for example, how do I determine the sign for 2x minus 6? It's 0 here at 3. I will plug in negative 10, and I see I get a negative number. I will plug in positive 10. I calculate, and I will get a positive number. You don't have to think in terms of the end behavior. I think it's easier. You can plug in numbers to get the signs. Okay, so now what happens on the first subinterval? The first factor is negative. The second one is positive. The third one is negative, and the fourth one is negative. What will be the sign when I don't even count positives, when I multiply 3 negatives? That's it. Now on the next subinterval, I count negatives, and I see 2. What is the sign? On the next subinterval, I only see 1 negative. On the next subinterval, I see 2 negatives. A negative here and a negative here. And on the last one, I see 1 negative. So now I have to choose. I choose based on this. This symbol tells me what to choose. What sign is less than or equal to number? If you say positive, then we have to choose positive. If you say negative, which I hope, then we have to choose negative. Negative. So is this product ever negative? For which x values?
Wait, how do we know that's negative?
You can just calculate it. We just calculated the sign of the product. So I see it's negative here for that x. It's negative here for that x. And it's negative here for that x. That's the solution. If I choose a negative 4, do you think that the product will be positive or negative? Of course. If I choose 1, do you think the product will be positive or negative? Of course. If I choose 10, will the product will be positive or negative? Of course. So then the solution is solution x in the interval. Can anyone dictate? -5, and we'll have to use the bracket because of the equal symbol. Union with a bracket, very good, and union 3 to infinity. This is it.
How did you get that? I was going to say -5 too. Oh.
Better? Okay. So this is basically the end of the material, but I would like to look at a rational inequality as well. Let's make one up. Let's say this time is greater than or equal to 0, but it's rational. Come up with any factors you want. Okay, I will write the denominator. And you give me the numerator. X minus 2. Okay. And awesome. Can I change it into negative x plus 3? Only because if I factor x -1 here, then I will cancel one factor, and I really don't want to cancel anything. I want to keep all of them. How many factors we will have in this table? Yes, 1, 2, 3, 4, 5. So x is the variable in the problem. X is the first factor. X minus 2 is the second one. Negative x plus 3 is the third one. Negative x minus 3 is the fourth. X plus 2 is the last. And of course, I ran out of room, so I'm going to write ratio this time. On the side, let's determine all the values that we need to have in the table before we put them in, so we put them in the correct order. What value will you put for this? Perfect. What value will you put for this? For x minus 2, we'll have 2. For this one, you're right, 3. Perfect. For this? Very good. For this? Negative 2. Now we have the list, complete list, and now we're ready to put them in. From left to right. Very good. This is way more sophisticated than what you're going to see on the test. You're going to see probably 3 factors, but let's say, okay, we are playing now. Okay, x has a 0 somewhere. X minus 2. Negative x plus 3. Negative x minus 3. And x plus 2. Good. Now you have to be very careful. Look at the rational inequality and tell me what happens under negative 3. Careful. If the numerator is 0, the fraction is 0. If the denominator is 0, the fraction is? Thank you. Thank you. Under negative 2, please. Undefined, very good. Under 0, please. 0. Under 2? Perfect. Under 3? Awesome. Okay, so 1, 2, 3, these 3 are linear functions with a positive slope. What will be the sequence of signs so we can finish them up quickly?
Wait, there's 2 negatives.
1, 2, 3. They have a positive slope. What is the sequence of signs for those? Good. These 2 have a negative slope, but just always remember, they have to be in descending order. Because if you don't put them in descending order, you may mistakenly identify something else, right, instead of the slope. Always, always descending order, okay? So what is the sequence of signs for these 2? Okay. We are looking at the first subinterval. I'm only counting negatives. 1, 2, 3. Sign. Counting negatives now. Second in subinterval. 1, 2, 3, 4. On the next one. 1, 2, 3. On the next one. 1, 2. On the next one, 1 negative. And on the last one, 2 negatives. Okay, now I'm asking myself, what does this say to me? What do I have to pick? What sign do I want this to have? This whole thing, the ratio. What's positive? Is the ratio ever positive? Yes, it's positive here, and here, and here. But I don't care about that. I need to find x. So this is what I'm going to write, and this is what I'm going to write, and this is what I'm going to write. That's where the product is positive. If I choose x between negative 3 and negative 2, between 0 and 2, or between 3 and infinity. That's where the ratio is positive. So solution, x in the interval.
Parentheses, -3, -2 plus x.
Can anyone explain other than Stephen why we use parentheses? We have the equal symbol here. Why do we use parentheses around -3 and -2? Because it's undefined. I should have said not Deborah. Good. Then, yes, 0 to 2. Between -2 and 0 is negative. And then union. Very good. I hope you find this like a little puzzle. And now you can say, when am I going to use this? Well, not in this course. Okay, so now let's start the review for test 2. Was it clear? Was this clear? The table? Okay. So that's how we solve polynomial and rational inequalities. So one more time, I emailed everyone, Randall Mills and 401, starting from 7:30 to 8:30 a.m. this Saturday, the 27th. If you come in earlier, I'll be there. If you cannot make it, it's not mandatory. If you cannot make it, I will post this on Canvas, so it's up to you. If you can make it, as I said, you can wear your PJs. You will be excused. Okay, so let's start with, one of my students said that he's going to have a hangover by then. So I said, well, everyone has his or her priorities. You do what you need to do. There is nothing I can do about that. So then f of x equals 3 divided by x squared minus 2x minus 120. And we're asked to find the domain of this function in interval notation. First, I have to ask myself, what type of function is this? If it's a rational function, then I know immediately that the denominator cannot be, yes. So I have to write that x squared minus 2x minus 120 cannot be 0. Now, if it takes more than 20 seconds to factor, forget about factoring. What will you use? Conventional square? No. I'm not saying that you would have said that. Quadratic formula, indeed. So can we factor it right away or quadratic formula? We can? Okay, very good. Then what is the factor form? So there are two options then. For x not to be. And perfect. So the problem is really asking us what x can be, not what x cannot be.
So is it saying
Yes?
-10?
That's it. Very good team. Very good teamwork, both of you. So then we have g of x, the square root of x minus 5 over x minus 8.
That's number 2.
Yes. Yes. So now here's a question for you. What type of function is this? It looks like a rational, but it's more sophisticated because the top is not a polynomial. The top is a rational, is a radical function. So this is a combination, not a combo, a composite, but this is a ratio of two functions. So now I have to worry about two things here. What are those two things? That I have to worry about. I have to worry about that x cannot be 8, of course, that's very clear. Absolutely. So x minus 8 cannot be 0, that's very clear, like we just did.
The top can't be less than 0.
Okay.
Well, it must be.
So what do I write as? Yes, but when you say the top, what do you really mean? Yes.
X plus minus 5.
Exactly, not the square root. So do not copy the square root. It's the quantity under the square root that has to be greater than or equal to 0. Very good, awesome. So then there are two restrictions. X cannot be 8, and X must be greater than or equal to 5. You do not have to graph, but I will graph this because I want to explain. But you don't have to graph if you can see the solution without graphing, right? So X not equal 8. So this is 8. I'm going to say not 8. Greater than or equal to 5. I don't care for units, as you know. This is just to come up with the correct solution. I don't really care for anything else here. So then my question is, what is a domain? And how do I write it?
Bracket 5, 8, parentheses, union, 8,
Indeed, this is the function, it's the domain. Why? Because it has two different pieces that have to be evaluated. One piece was the denominator cannot be 0. The other one is the square root. And the square root requires the quantity under it to be greater than or equal to 0. Very good. Thank you. Any questions so far?
Why is there a bracket on 8?
But if I put a bracket, that does not that mean that it includes 8?
Oh, and there's not 8. Okay.
Very good. Okay, number 3. We are given f of x, which is x minus 5. And we are given g of x, which is 3x squared minus 5. We are asked to find f comma g of x.
X squared minus 10.
So I have to write, yes, f of g of x. You're way ahead of me, like always, and I know that. That's awesome. So f of g of x is the same with f of 3x squared minus 5. So now I have to look at f, and remember this is what f says. F says of f was whatever you want, it's whatever, the same thing, minus 5. So indeed we will have to write 3x squared minus 5. Minus 5, very good. So this is 3x squared minus 10. So this is f comma g. We're also asked to find f comma g of 0. Since I have the function, I want to do that first, and then move on. So f comma g of 0 is perfect. Okay, next it's g comma f of x.